Now, going back to our case, the MR images are then sent to the Visage PACS for storage and to the icometrix, icobrain, ARIA, and Siemens AI RAD companion algorithms. Now, before we take a look at the AI results, all of you should recognize that our imaging work list is actually seen within Epic, and that is helping us drive our imaging work list. That is just one way of doing things. Another way would be to use your PACS to drive your imaging workflow as well. So, let's turn our attention to the icometrix, icobrain, ARIA, which is an AI assistive tool for automated detection and quantification of ARIA. The AI results in our case are presented in the Fovea AI cockpit viewer, which should come up shortly. And what we're going to see within the viewer is findings concerning for both ARIA-E and ARIA-H, noted with segmentation overlays on the original MRI images, which you can see on the right on the screen. So as I wait for the screen to come up, we'll go back to what our AI results show, which you can see now. The icometrix icobrain ARIA AI tool helps us to detect and quantify ARIA in brain MRIs using T2 and FLAIR sequences. The algorithm quantifies edema, gyral swelling, as well as sulcal effusion in the case of ARIA-E, and in the case of ARIA-H, it helps highlight microhemorrhages as well as superficial siderosis. For each ARIA marker, the icobrain ARIA calculates a severity score based on the FDA safety label, and it includes it within the report, highlighting the key metrics used to develop that score. Icobrain ARIA even helps detect subtle changes which are sometimes missed by the radiologist. Now, in our case, the AI result shows that there is increased edema at the left greater than right frontal, parietal, and occipital lobes, compared to the brain MRI from January. We also see increased foci of microhemorrhages and superficial siderosis at the frontal and parietal lobes. Just as a reminder, the AI results are also available to review within Visage 7 PACS for immediate review as well as future comparison on follow-up studies. Okay, so now let's get to most important part of what we do, which is dictating our findings. It's a lot of information to report that we just went over. Typing in numeric results in AI findings is a tedious job for radiologists. But here, as you can see on the left TV, the values are automatically sent to Nuance PowerScribe 1, which then populates the appropriate fields in the report. Because the AI results are coded in the RadLex lexicon and other coding systems, the AI results are easily and automatically populated into the report template. Please note that for the purposes of our demo, this is only an abbreviated version of the report. Again, I want to emphasize that none of the values or the observations that you see within the report were actually dictated by the radiologist. They were all auto-populated. Now, as an aside, you may have noticed that all of these different applications that I'm talking about opened correctly to the correct patient as well as the correct study. This is possible using FHIRcast context sensitivity. FHIRcast is a standard that synchronizes clinical applications such as the EHR, PACS, reporting systems, and the various AI tools that I've mentioned here today to a particular patient and specific study. It enables different applications to look at the same patient securely. Under the hood, Visage has shared the AI results with both Nuance PowerScribe 1 and Epic Radiant via FHIRcast. The upcoming versions of FHIRcast will also facilitate the exchange of measurements and AI findings, and you are getting a sneak preview of that here today. Sharing the data like AI results and/or measurements enables another exciting development in standards, the exchange of real-time data for convenient embedding into the radiology report via IHE integration reporting applications. So returning back to our patient, the report is now sent to Laurel Bridge AI Workflow Suite, where it can then be distributed to the EHR and other systems.